Hello students, welcome to another session of this three-dimensional geometry. In the last class I derived one expression for shortest distance between two skew lines, and today we will be dealing with problems on the shortest distance between two lines. So suppose here L1 and L2 are two lines in vector form in this form. So the shortest distance between them is given by this. So from given example, first you need to find what are vectors a1, a2, b1, b2, and you have to find a2 vector minus a1 and b1 cross b2 and their dot product and magnitude of b1 cross b2 and substitute here. That's the thing. So first you need to compare the given equation with these two equations. So let's have first example. So find the shortest distance between the lines this and this. So pause the video, note down and keep writing so as to make your own notes. So compare these two with these two equations and what are a1, a2. So this is your a1 vector and this is your a2 vector. And I need a2 minus a1 as you saw in the previous page. In the formula we need a2 minus a1. So find a2 minus a1, subtract. So 2i minus I. Okay, so 2i minus I is I. Subtract. So minus j, and if you subtract means change the sign. You can do like this. So change the sign of above vector and you can add them. That's the thing. So if I do like this, if I change the sign, so change the sign here of this and this, that is your minus a1. Okay, so changing the sign and adding like 2i minus I, that gives you I, and 2i, that's minus j, minus 2j gives you minus 3j, minus 2k, that's minus k gives you minus 2k. So this is your a2 minus a1. So you have to find. Next, b1 b2 stands for this, comparing this with this. So this is your b1 vector and this is your b2 vector. So you need to find what is b1 cross b2. So let's see how the b1 cross b2, as we know how to find cross product of two vectors in the form of determinant that we studied in vector algebra. So I cap, j cap, k cap, these are the coefficients of I, j, k in b1 and these are the coefficients of vector b2. Okay, I, j, k coefficients. Now as we all know in the determinant how we can expand. So using that method you expand and you will come up with this. So note down. So simply watching that never helps. So now you have to find magnitude of this vector. So magnitude means sum of under root, you can write sum of the squares of the coefficients of I, j, k. So minus 3 square becomes positive. So simply you can write 3 square, 0 square, 3 square. So 9 plus 9, that is 18, and 18 can be written as 9 into 2. So square root of 9 is 3. So 3 root 2 is the magnitude of b1 cross b2. So next is the dot product of this and a2 minus a1. Okay, so this is your dot product of b1 cross b2 dot a2 minus a1. So this is your b1 cross b2 and this is your a2 minus a1, and we know how to find dot product of two vectors, that is sum of the product of the coefficients of I, j, k, that is a1, a2, b1, b2, c1, c2, that we studied in vector algebra. So there you go and search for the dot product or scalar product of two vectors. So you will find how you can find dot product. So minus 3 into 1, 0 into minus 3, minus, that is 3 into minus 2. So simplify this, you will get minus 9. So this is the dot product of these two vectors. Okay. Now the shortest distance between two lines is given by this formula, and we have everything with us. We have this as a minus 9 that we found here, and the magnitude of this we found in the last page, that is 3 root 2. So 3 ones are 3 threes are, and being distance is always a positive, so that is why we are putting here mod. So minus removes, so 3 by root 2, or you can keep as this as it is, or you can rationalize, means multiply and divide by root 2. If you multiply and divide by root 2, so 3 root 2 and root into root 2, that gives you 2. So either you can keep this much, no problem. Okay. So in this way you can find shortest distance between two lines in vector form. So let's have one more example. Find the shortest distance between the lines, this and this. Better to note down. Comparing these two equations with the standard vector equations, and what are a1, a2 vectors and b1, b2 vectors. Okay, so comparing these two with this, so this is your a1, a2, and this is your b1, b2 vectors. So now you have to find a2 minus a1 vector. So a2 minus a1 is, as said I earlier, change the sign. Okay, so 4i minus I, you will get 3i, 5j minus 2j, that gives you 3j, 6k cap minus 3k cap, that gives you 3k cap. Okay, so just subtract. Now you have to find cross product of b1 and b2. So see here how the b1 cross b2 is found. The determinant expansion, and this you will get, everything is explained in detail. So pause the video and try to understand yourself. So this is your b1 cross b2, and its magnitude is, as I said earlier, under root you can square and find the sum of the squares, that is 9 square, 3 square, 9 square. Don't get confused, minus 9 square is what? So if you square this, it becomes positive. So go on writing only positive values. So on simplification, you will get square root of 171. So if you want further, or if you know, you can express 19 nines are 179, 171. So square root of 9 is 3. So you can write this much. So now find the dot product of b1 cross b2 and a2 minus a1 that we did in the last example. Okay, so the dot product of these two. So this is your b1 cross b2, this is a2 minus a1, sum of the product of the coefficients of ijk. So minus 9 into 3 plus 3 into 3 plus 9 into 3. Simplify this, you will get 9. Now last but not the least, substitute in the formula. So in this formula you have to substitute the values that you know. So the value of this is 9, and the value of this we obtained, that is 3 root 19. So 3 ones are 3 threes are, so 3 by square root of 19 is the shortest distance between two given lines. So I will be giving one example for you as a homework and to make you perfect. So because from the point of examination you may expect one question of such kind. So this is the example for your practice. So find the shortest distance between the lines, these two. So the final answer will be this one, 10 by square root of 59. So please do this. Better you take screenshot. So one more special example. So I will be just introduce you and I will leave it to you. Okay. So find the shortest distance between the lines. Vector r is equal to 1 minus t I cap plus t minus 2j cap 3 minus 2t k cap, and here is in terms of again s parameter, s plus 1 I cap 2s minus 1 j cap minus 2s plus 1 k cap. Here instead of lambda and mu, t and s are given. So, okay, so t and s are, they are constants like lambda and mu. So first you need to express, means terms with t and terms without t. Here also you can expand it and collect the terms with yes and terms without yes. So that we do here. So given can be written as, this is your first equation. So first you expand it. So I into 1 I cap, I into t, that is minus t I cap. Next t into j cap, t j cap minus 2 j cap. Next 3 into k, t k cap minus 2 t k cap. Now collect the terms with t and without t. So the terms with t have been marked red, okay, and without t. So I minus, here minus is repeated twice, so you can make it only one minus, okay. So and minus, that is plus 3k you have to make. So make one correction out here. So this you make as a minus and this is your plus 3k. Now terms without, that's with t. So this is your t, t term and t term. So taking t common from this, so you left with minus I cap, here plus j cap, and here minus 2k cap. So this is your a1 and this is your vector b1. Okay. So in this way you have to express the given in the standard form. This is vector a1, this is vector b1. So similarly we expand this second equation. So expanding this, as earlier, multiply term by term. Okay. So collect terms with s and without s. So with s are these one. So taking s common, you left with I plus 2j and minus 2k, and without s are I minus j minus k. So this is your vector a2 and this is your vector b2. Okay. So using this information, you substitute or find a2 minus a1 b1 cross b2 and their dot product and substitute in the formula, you will come up with this. So please try this. So this is all about how you can apply the formula to find shorter distance when the lines are given in vector form. Now we'll do two more examples on Cartesian form. Okay. So we know that the shortest distance between the Cartesian form, means if the lines are given in the Cartesian form, in this form that we studied, and the shortest distance between these lines is given by this formula that we discussed in the last class. Okay. So same procedure, you have to compare the given two equations with these two equations and find what are x1 y1 z1 and x2 y2 z2. Similarly, find the direction ratios a1 b1 c1 a2 b2 c2. Before, and in order to find x1 y1 z1 x2 y2 z2, you must compare that with this equation. means x, it has to be x minus x1 form. Okay, so let's see here. Here is the first example. Find the shortest distance between the lines, these two. Okay, so let's see here. Clearly the coefficients of x, y, z are 1, 1, 1. So you can write directly the direction ratios, that is a1, b1, c1, and these are a2, b2, c2 denominators. Okay, so whenever the in order to decide the direction ratios, the coefficients of x, y, z must be always 1. Okay. So this is your first equation. So what is x1 is, you have to write, or one can write directly. So x1 is minus 1 here. Okay, otherwise I can show you. So this can be expressed as x minus of minus 1, and y plus 1 can be written as y minus of minus 1, and z plus 1 can be written as z minus of minus 1. So this is of the form x minus x1 by a1, y minus y1 by b1, and z minus z1 by c1. Okay, so here x1, y1, z1 are minus 1, minus 1, minus 1. So one can write directly from the given equation. So these are the x1, y1, z1, and the denominators are the a1, b1, c1. They are the direction ratios of this line. So similarly, compare this with given equation, that is standard equation, and find x2, y2, z2. So directly this is your x2, y2, z2, because already it is in the standard form. And the direction ratios a2, b2, c2 are 1, minus 2, 1. Okay, so here are they. Now only thing is that substitute in the formula. So here is the formula. So everything we have, x1, x2, y1, y2, z1, z2. So substitute here. So on substitution, you will get this. Now look at this. Actually, this is nothing but it follows the determinant expansion method. So first is, you can write minus 6 into 1 minus of minus 2 into 1. That gives you this. Here it is 7 into 1 minus minus 1 whole square. Next, this is 7 into minus 2, that's minus 14, minus of 6 into minus 1, that is, it becomes plus 6. So this is easy, so that you do in determinant. Okay, so it follows the same pattern. Here you have square, square, square. So just I told you. Okay, so the rest of the thing is expand. So 3, it becomes minus of minus plus 1, it becomes 4, 5 plus 1, that gives you 6, 1 plus 1, that gives you 2, and rest of the thing as it is. Now the simplification of this, minus 6 plus 2 is minus 4, 7 minus 6 is 7 minus 1 is 6, and this gives you minus 8. So everything is now simple. So expand this determinant by the known expansion method. So that gives you, if we expand it, okay, so determinant expansion, in the numerator we will get this, denominator as it is. So simplify, everything is simplification. So this much. Just pause the video and try yourself. You will come up with this result. Okay. So simplify further. So 4 into minus 4, that's minus 16. 6 into 636 as it is. So add this, we'll get minus 116, and in the denominator we'll get under root 116. So mod means you can remove minus. So we'll get 116 by root 116. So as we know, or you can multiply and divide by root 116 to rationalize it, or one can write directly, it is square root of 116, because x by root x is root x. So, or if you don't know, then follow this, multiply and divide by square root of 116. So that is here. So square root of 116 into square root of 116 becomes 116. So it becomes 116, the product of these two. Now these two cancels, you will left with square root of 116, and that is nothing but 29 fours are. If you know, then you can write 29 fours are 116. So square root of 4 is 2. Otherwise you can stop at this stage. no issue. Okay, so this is how you can find shortest distance between Cartesian lines. So we'll have one more example. Find the shortest distance between the lines, this and this. So as I said, compare this with the given standard equations and find immediately x1, y1, z1 and x2, y2, z2. Okay. So what are x1, y1, z1? Minus 3, minus 2 and 1. So x2, y2, z2 are 2, minus 3, minus 1. And these are a1, b1, c1 and these are a2, b2, c2. Once if you know these, everything is simple then. Okay. So on comparing these with the standard equations, so you will come up with these values. So now you substitute in this equation. You have to do yourself. Okay, I had given you idea. Okay. So substitute. This is the thing that you get after substitution. Okay. So I will just to show the time. I will be giving everything here. So better you pause the video, do yourself and verify your result. Nothing is left to explain because everything that I explained the last problem. So final result will be 4 by root 3 because 7 ones are 7 fours are 28. Okay. So whenever you get negative, remove that because distance is always a positive quantity. So this is all about how you can find the shortest distance between two lines both in Cartesian form and vector form. So please practice more and more. You can get one question definitely for 3 marks. Okay, so that's all. So please keep working and watch all my videos, and if you like, subscribe to my channel. Okay.